channel. This is R. Divyanjali from Pantech. Today we have come up to the workshop on data science. This workshop is being conducted by Sathak Engineering College. Firstly, I would like to welcome the convener of the event, Dr. B. Aisha Banu, Department of IT, MSc. And I would like to welcome all the participants to the session. My dear participants, before starting the session, first let me know whether am I audible to all of you? My dear participants, am I audible to all of you? So, my dear participants, without any delay, we will move on to the session. Data science. What is this data science? Why this field has become so trending nowadays? The word itself is describing as something like data science, scientifically analyzing the data. Okay. So, once again I am telling you, data science is a field of AI branch completely. So what this data science is going to do? We will analyze the data scientifically, analyze the data graphically, theoretically. Fine. So in this data science, what we are going to do? Analyze the data, right? Here today we are going to work with some application. So it is cyber money laundering detection using machine learning methods. So what is this machine learning again? We might have heard about AI technology, right? Artificial intelligence technology, which is nothing but inserting our human brain intelligence system into a small computer so that the computer will have the ability or capability to work same like our human brain. We know that it is not a simple task, right? That's why there were number of research and development works which are going on under this research and development works. That's why there were number of domains came into existence. What are those domains? Something like machine learning, deep learning, data science, image processing, OpenCV, all these domains came into existence. What is this machine learning? Machine learning in simple words can be defined like a machine or a system which will be learning from past experiences, previous experiences, or something like historical data. It will be learning from that data, and using that data it will try to improvise the present task or present application. Next is deep learning. What is this deep learning? In simple words, we can tell like here we are going to work with neural networks. We create or build any neural network and we work with neural networks. Next comes NLP technique. Generally in machine learning, we generally take the input like data sets. But here in this NLP technique, we are going to work with something like sentence or paragraph format information. Image processing means where we work with some set of images, videos like that. Fine. Today we have come up to the application of cyber money laundering detection using machine learning methods. What is this cyber money laundering detection? Have you heard about it before? The title of the application is little bit interesting. The application also will be very nice if you can listen. Okay, cyber money laundering means, for suppose, if a person A is transferring some amount to a person B, something like 500 rupees. At the back end, it is getting hacked. The account gets hacked and deducting the account balance. More amount is deducted. So that is called cyber money laundering. We have to find it using different algorithms or neural networks like that. Let us first go through the abstract. So let me first read out the sentences over here. Money laundering is the process of taking cash earned from illicit activities such as drug trafficking and making the cash appears to be earnings from the legal business activity. The money from the illicit activity is considered dirty and the process launders the money to make it to look clean. Today, money laundering poses a serious threat not only to financial institutions but also to the nation. This criminal activity is becoming more and more sophisticated and seems to have moved from the glitch of drug trafficking to the financial terrorism and surely not forgetting personal gain. Most international financial institutions have been implementing anti-money laundering solutions to fight investment fraud. Recently, data mining approaches have been developed and are considered as well-suited techniques for detecting the money laundering activities. So, here what we are going to do, we apply different machine learning or deep learning networks and find out the predictions. Let us know in detail about this network or something like in detail about the process. Okay. First, we generally give some input data. It will process the information, extract the information, and then it will give the future prediction. Machine learning main implementation is to predict the future. Okay. Fine. Here comes the problem statement. So, the purpose of our application is to develop, describe, and validate a machine learning model for prioritizing which financial transactions should be manually investigated for potential money laundering. There were a number of approaches which are already present in the existing system. Something like clustering implementation, classification and prediction. So these were all the different implementations that have been already done. Okay. With number of titles and their objective, their algorithm implementation might be different. But the only disadvantage is accuracy level. We already know the output. Okay. We would like to know how much accurately the data can be predicted. So that is why in the proposed system we apply different machine learning, deep learning models and find out the prediction levels. So here is how we are going to work with our application. First, collect the input data, that is data ingestion block, which is nothing but collect the input data in the form of data set. Okay. So our input will be in the form of a data set. Data set is nothing but collection of number of rows and number of columns. That input data will be given to a pre-processing stage where we have two main steps: data cleaning, data transformation, which is nothing but filtering our input data by eliminating unwanted data like null values, white spaces, symbols. Such type of data will be eliminated and the data that is utilized for further predictions will be filtered over this step, pre-processing step. Next comes exploratory data analysis. It is nothing but analyzing our input data in graphical format. Why we have to analyze? We already had the input. Why? Why? Because a system or an algorithm or any model can understand our data in the easiest way if and only if we represent that data in graph. Okay, so that's why we explore the data, input data in graphical format. Next comes building and training models. So why it has come this step, I'll tell you something. For suppose if I am giving some input data to the system and asking the system or model or algorithm to give predictions, do you think it can give? No. It is nothing, it is just like a doll. A system don't have that much knowledge. It is just a doll. We created it, right? So that's why we have to train it what our input data is actually consisting of. That's why we train the model first, then that model will give us the output predictions. Fine. Let us move on to the next slide. Here are the proposed approach steps. First one, we take the transactions data, then we filter the data set according to the requirement which has attributes according to analysis to be done. Next, split the data into training and testing category. Next, perform smooth for balancing the data on resultant dataset font. Analysis can be done on testing data after training using logistic and random forest and neural network as well. Finally, we get the output in terms of accuracy level. How much accurately we are going to get the output. What are the algorithms we have implemented? Logistic regression, random forest and some neural network as well. So sorry for the interruption. So in data pre-processing, we will have these three categories or three main steps. One is formatting, second one cleaning, third one sampling. Formatting means that whatever the input data we are having, it might not be in a proper format to work with. So we convert the improper data into proper format. Then we clean or filter the data by eliminating unwanted data present in our input. Next, sample the complete data into number of samples. Feature extraction. Here we just apply correlation function which will give us the relation between every two attributes present in my input data. So, it's a value between -1 and +1 that represents how closely values for two separate features move in unison. Positive correlation means that as one feature increases, the other also increases. Like a person's age and her height. Okay. Next, negative correlation means if one feature increases, the other will decrease. Hours spent studying and the number of parties attended. Correlations near to -1 or +1 indicates a strong relationship. Those closer to 0 indicates a weak relationship. 0 indicates no relationship. Evaluation metrics. This is nothing but an output block, okay, where we apply the algorithms or implementations or any techniques, then find out the outputs. The main output is accuracy level. How much correctly, accurately we are able to find the predictions. That is the first output. And system internally will calculate certain values like precision rate value, recall value, F1 score value. Such calculations will be given in a report format which is called as classification report. So now let us see this in practical, how we are going to implement it in practical way. downloading the input data so then we can work on the application. Just give me 1 minute. Let this file be downloaded. Yeah. So this is my file which I have been already downloaded. Now let us see what is the input data actually consisting of. So the complete Excel sheet is in the form of related to transactions, okay? Payment, amount, name origination, old balance, new balance, name destination, old balance destination, new balance destination, is fraud, is flagged, okay? Fine. We'll implement this in Google Collaboratory. Go to Google Chrome and type Google Collaboratory. Click on enter. You can see here, welcome to Collaboratory, right? Just click on this. Generally, my file is already there. If you want to implement by yourself for practice purpose, you can just click on this new notebook. I hope everyone understanding. So in order to start or work with an application, first we need input, right? That input I have to access here. Before accessing input data, we are working with Google Collaboratory, which is nothing but online implementation, okay? Implementation in online, that's it, in Google. Okay, generally in which software we implement means, I can tell like, we implement our project or implementations of applications in Anaconda Navigator software, in Jupyter Notebook Editor window, in Python language. I repeat it once again, we are going to implement the project or application in Anaconda Navigator software, in Jupyter Notebook Editor window, in Python language. How to access the input here? Just go to this third option where you will be finding something like yeah, we got here. Here you have to select the input file. This is your input file. Click on open. It will be coming here. It's loading. Let us just wait. My file is already there, so I'll just explain you here. Let's just wait. It's a very big file. Just wait, it is loading. Okay. So let it load. I already executed the code. I'll just explain you here. Okay. Okay. So I have told you that we have 5 steps, right? First one, we collect the input data. Next, we pre-process the information. Next, we explore the data in graphical format, and then we categorize the data into training and testing category. Then we apply the algorithm, right? So to work with any input, we need to have few library files, okay? Python library files. What are they? First one, pandas. Second one, numpy. Third one, matplot library. Fourth one, seaborn library. Fifth one, sklearn library file. Once again I am telling you, we have 5 library files which are very much important. First one, pandas. Second one, numpy. Third one, matplot library. Fourth one, seaborn. Fifth one, sklearn library. What these library files are used for? Let us discuss each of them. First one, pandas, right? Pandas library file is used for accessing of input data. To access any input data, we use this pandas library file. So we import this pandas as PD variable. Here, PD is just a variable. We can give any variable representation over here. Next is import seaborn as SNS variable. Seaborn is nothing but a library file which is basically used for customization purpose. What type of customization? For suppose if we visualize the data in graphical format, then something has to be done. Something like to make our graph attractive, we use this seaborn library file. Customization like size, length, color indications, and it is represented with SNS variable. Next, import matplot library dot pyplot module as PLT variable. Matplot library is used for visualizing the data in graphical format. NumPy. NumPy is used for numerical values accessing purpose, and it is represented with NP variable. Next, from implearn.oversampling, I have imported smooth module. So implearn is nothing but a library file, machine learning library file. Smooth is a module which is used for balancing the input data. Next, sklearn. Sklearn is a library file which is used for accessing of machine learning modules or machine learning algorithms. So from sklearn sklearn.model selection technique, I have imported train test split module, which is basically used to split the data into training and testing category. Next, from sklearn.metrics, import classification report. Metrics is a module used for mathematical calculation purpose. So from there import the classification report, where in this report I am going to get certain calculations which system internally will be calculating. Okay, what are the calculations? Precision rate value, recall value, F1 score value. Now from sklearn.matrix import confusion matrix, where I am going to plot my output data in a matrix format. Next, accuracy score, where I am going to get my output predictions with certain accuracy level. Next, sequential, dense, these are the layers of neural network. Next, import accuracy score, import warnings which are to be neglected. So I have considered my input library files. The next step is access the input data. CSV means Excel sheet, okay? Something like data set. Our input file, I am reading into the program with the help of pandas library file, and I am storing in a very small variable called df. So here in my program, complete Excel sheet is in a very small variable which is called df. We can give any variable. Here I gave df. Now next I have given header function. Header function by default displays first 5 rows of data. Starting from the index value 0, 1, 2, 3, 4, with all the columns it is going to display. Next, so header function displays first 5 rows. Next is information block. Information block describes what type of information is present in each and every column, whether it is integer type, object oriented, floating, like that. Okay, integers, like that it will be describing what type of input I am going to have in my Excel sheet, in my columns, input data columns. Next is describe function. It will describe certain values like count value, mean value, standard deviation value, minimum maximum value, 25%, 50%, 75% values. Next, I have applied is null dot values. It means whether there are any null values present. If present, it will describe true, else it will describe false. We got here as false. Next, drop these name origination, name destination, is flagged fraud. These columns I am dropping. Dropping means eliminating. Okay. Next, now I am grouping the complete steps, like complete Excel sheet as is fraud column. For each and every parameter I'll check. Okay. You can see here, step, amount, old balance, new balance, old balance, destination, origination, is fraud. All the columns I am graphically visualizing. I am doing nothing new here. The same input data, whatever I am having, the same data I am visualizing in graph. Okay. Next. Here I have applied correlation function and stored the correlated data in this variable. Correlation will describe or illustrates the relation between every two attributes present in my input. Title given as correlation matrix. Now with the help of heat map, I am going to plot the correlation matrix. This is the correlation matrix. Okay. Now I am getting the dummies of type column information. I will have at last type column, right? That dummies mean duplicate. Okay. That column values I am duplicating, again I am storing in the same variable. Now concatenating this df and dum variables. Okay, concatenate means add or join. Now that added content will be stored in this variable. Now drop type column information. Drop means eliminate. When I give this variable name, you can see here my complete Excel sheet is displayed. Okay. Now take some sample information from my Excel sheet, something like I gave here 20,000 to row. That row information I stored in variable. For this I am value counting the information and plot the data in bar chart. Now check is fraud dot values, whether there are any fraud is present or not. That I have to categorize. Is fraud, not. Okay. Now taken this train test split module to x and y variables. Okay. Except is product, all the columns to be stored in one variable. Only is prod I am storing in one variable. So this is x, this is y. X and y has been considered. Now I have to divide this complete x and y. X means input, y means output. Okay. So test size I gave here something like 0.3. It means 30% data. Remaining 70% will be given to training purpose. Train the model or algorithm. For that purpose, we use this. Now random states 0 I have considered. We can take any number of random states. It might be 0, 50, 100 like that. Okay. Now before oversampling, how many are coming under 0 and 1? After oversampling, how many are coming under zeros and ones? That I am getting here. You can see the plotting also. Okay. Now from sklearn.preprocessing stage, import standard scalar module, which is used to normalize the input data, taking the model into a variable. Next, fitting the training data to this variable. For training and testing data, I have been applied the standard scalar module and the normalized data is stored in this variable. Now, from sklearn.ensembling technique, import random forest classifier algorithm, which is basically used to check for multiple conditions. For multiple conditions, we will have multiple outputs. For suppose if I have 3 inputs, I will have 3 outputs as well. Based on majority voted output, the actual output will be determined. Now taking the algorithm into a variable, next I am fitting the training data to this variable, next prediction to be calculated with the help of X test data, next print the accuracy, where I am going to calculate with the help of Y test and Y prediction values. How much accurate result I got? 0.99. It means 99% accurately random forest algorithm is able to predict the input data. Next, from sklearn.linear model selection, import logistic regression, where it will plot my input data in S-curve format. Now taking the algorithm into a variable, next fitting the training data to this variable, next prediction to be calculated with the help of X test data. Now calculate the score with the help of Y test and Y prediction values. 0.97 is my output. 0.97 means 97% accurately I am able to predict the data, input data. Next I am going to apply the LSTM neural network. Okay. So sequential is nothing but input block, where I am taking this module into a model variable. Now add the dense layers, which are nothing but hidden layers with some parameters. Next compile the data, next fit the training data to that. Here epochs I gave 10, right? For each and every epoch of my data, it will give me the loss and accuracy levels. I gave 10, right? So 1 by 10, 2 by 10, 3 by 10. For each and every epoch, it will give the loss value, accuracy value. Okay? Fine. Now define plot model history. Now subplot the data. For axis 0 and axis 1, I am going to give the title X label, Y label, legend block. Okay? Next, model history. You can see here the model accuracy, model loss. Okay? Legend means a very small block which is present over here. Okay? Model accuracy level. How much accuracy we got? Last is 0.97. Okay? Model loss. Model loss is getting decreased as the accuracy is increasing. Okay? Now, Y prediction to be calculated with the help of X test. Now, calculate the score with the help of Y test and Y prediction values. Now, print the accuracy level. You can see here confusion matrix and classification report. How much accuracy I got here? 96%. And here you can see the confusion matrix, then classification report. In this confusion matrix, we have 2 rows, 2 columns, right? The first column represents the actually truly given data. The second row represents the predicted information. Next is classification report, where system internally will calculate certain values like precision rate value, recall value, F1 score value. Support means number of variables coming under zeros and ones. The accuracy I got is 0.97, which is nothing but 97% accuracy level. Macro average and weighted averages are displayed for each and every precision, recall, F1 score values. So this is what, by comparison of the output accuracy levels, what we can tell, we can implement or we can illustrate or we can conclude that random forest algorithm is giving me best results for my input data. According to the data, it will change. Okay, for my problem statement, this algorithm can give the accurate results. That is what we have proved here. Okay, fine. So UML diagrams is nothing but representing the process in diagrammatical format. Okay, what will the user do? Will collect the information, right, input data. Remember one thing, my dear participants, we generally collect our input data from online websites. Okay, something like Kaggle, UCI repository, like that. So we give the input data to the system. Now the system comes into the consideration and pre-process, extract the features, split the data into training and testing. Now apply the algorithm, get the output results. Class diagram also. The user collects the data and gives to the system. Now the system will pre-process the information, apply the algorithm, get the results. Sequential diagram. Collect the information. Now the system will collect it, pre-process, extract the data, algorithm will be applied, output will be gained. Activity diagram. Here also we collect the data and pre-process the information, divide the data into training and testing category. Now randomly select the data, extract the features, apply the algorithm, classify the data into training and testing. Now get the output accuracy level. So what are the system requirements we have implemented in our system to implement our application? One is hardware and software requirements. Hardware of operating system Windows 7, 8, 10, anything you can use. 32-bit or 64-bit. Next, RAM should be 4 GB. Coming to the software requirements, we are going to implement our project in Anaconda Navigator software, in Jupyter Notebook Editor window, in Python language. In online also, we have implemented in Google Collaboratory. So we have found these data analysis, correlation matrix, output accuracy levels. So we can conclude which algorithm is giving us the best result. Random forest algorithm is giving you the best result for our application. I hope all the everything is clear. Any queries? I hope everything is clear. If you are having any queries, you can get back to us. We'll clear you in detail. Okay. So once again, I would like to thank all the participants for making the session so interactive. Next, I would like to thank the convener of the event, and I would like to thank each and everyone over the session. Thank you all. Have a very nice time.